Welcome students. In the previous lecture, we have seen some information about terpenes, terpenoids. Now here we are proceeding further. Now general properties of terpenoids. First, physical properties. Most of them are colorless. Of course, presents liquids lighter than water, having high refractive indices. They are generally insoluble in water but soluble in the organic solvents. Highly reactive, most terpenes are easily oxidizable and tend to rancify on exposure to air. Now, many unsaturated and some saturated cyclic terpenoids show geometrical isomerism. Generally, they are optically active and they possess antiseptic properties. Chemical properties. They are unsaturated compounds, open chain or a closed chain, that is cyclic, with one or more carbon atom rings having one or more double bonds. Consequently, terpenoids undergo addition reaction as they are unsaturated with hydrogen, halogen acids. Some of them forms hydrates. They also form characteristic addition product, and these products are found to be useful in the identification of terpenoids. That is, they are unsaturated, therefore these products are formed and they are useful for the identification of the structure of terpenoids. Number of addition products have antiseptic properties. Now, these undergo polymerization and also dehydrogenation in the ring. As they have polymeric bonds, they are very easily oxidized nearly by entire oxidizing agents. A number of terpenoids are liable and hence readily isomerize in the presence of and into more stable forms. Of course, on thermal decomposition, most of the terpenoids yield into the isoprene as one of the product. Now, classification of terpenoids. Yes, we have seen all terpenoid contains the isoprene unit, that is a C5H8 as a basic building unit. So they have general formula C5H8N, and based on the number of isoprene units present in them, they are classified. Okay, when the two isoprene units are present, the formula becomes C10, S16, and the name of the class is monoterpenoid. When three isoprene units are there, it is a sesquiterpenoid. The formula becomes C15H24. When four isoprene units are present, then it is known as a diterpenoid, having the formula C20H32. This is the when n equal to 5, then formula becomes C25H40, and the class is known as a sesterpenoids. When the isoprene units are 6, then the formula becomes C30H48, and the class is called as triterpenoids. And finally, when 8 isoprene units are there, the formula becomes C40H64, and the class is known as a tetraterpenoids, that is a carotenoids. And more than 8 units when present, they are known as a polyterpenoids. Okay, and therefore this classification is totally based on the number of isoprene units present in them. Okay, the simpler and mono and sesquiterpenes and the related oxygen containing substances are highly widespread in the plant kingdom. That is where they are present, the information is seen. Okay. Now, general methods of the structure determination of terpenoids. The method includes, first one is analytical method, that is analysis of the compound, then synthetical method, synthesis of the compound, physical method, the knowledge of the molecular rearrangement. Okay, synthetic method, that is the synthesis is carried out by taking starting material and finally the product is obtained. Okay, and these synthetical reactions for the determination of the structure of terpenoids is found to be great value. The first method is catalytical hydrogenation. Now, when aromatic compounds are hydrogenated catalytically under suitable conditions, it is possible to obtain the synthetic terpenoids. For example, a terpenoid alcohol, menthol, may be prepared from thymol, an aromatic compound by catalytical hydrogen. This is a thymol. On reduction, that is catalytically hydrogenation, this is a menthol, and therefore the that is the terpenoid is formed. Use of Grignard's reagent may give some terpenoids. The use of reformatory reactions, these reactions are given for the knowledge of how the terpenes are formed. Okay, here the reformatory reaction with a carbonyl compound using the Grignard's reagent, that is bromoethyl acetate in presence of zinc, the adduct is formed, and on hydrolysis the acid is obtained. And now by forming unsaturated acid, decarbonation gives hydrocarbon, that is a terpene. Physical methods are also used for the detection of terpenoid structure, that is how the structure is built up. Now, what is the isoprene rule? We have learned about the terpenoids contains isoprene units. What is isoprene rule? Dr. Walsh in 1887 observed that all terpenoids can be either broken into or built up from isoprene units, and he gave some example. The pyrolysis of rubber, that is a natural rubber, and other terpenoids give mainly isoprene as one of the main product. Here rubber, on pyrolysis heating, isoprene is one of the product. This is also isoprene, that is a dipentene. Here N equal to 2. While isoprene on polymerization gives rubber like polyterpenoid. Therefore, rubber is made up of isoprene units. Alpha terpenol on heating with potassium sulfate gives a dipentane, which is again the terpene. And these and other observations lead to them, that is to him, to propose the isoprene rule. What he stated? He stated that All terpenoids are made up of two or more basic units called isoprene, having the molecular formula C5H8, which are linked together to form larger molecule. That is why the molecular formula of terpenoid are simple multiples of C5H8 with or without water molecule. Okay, and therefore 1 unit, 2 unit, 3 units are linked to form larger. This is the isoprene skeleton. This is isoprene unit. Okay, CH2, CCH3, CH, CH2. Or this is the modern way of writing. How the carbons are? Here the carbon skeleton is shown. Okay. Now isoprene rule has been confirmed by the fact that isoprene gives dipentene. Isoprene can be polymerized to rubber-like compound. These are the two reactions. Now special isoprene rule. Further, the scientist Ingold in 1925 has observed that in many terpenoids, the isoprene units are joined in head to tail fashion. That is, head of one molecule is joined to the tail of another. What is the head? The branched end is head, while other end is a tail. For example, this is a branched end, therefore this is a head. This is other end, tail, branched end, head, other end, tail, and therefore joined head to tail fashion, head to tail fashion. This divided of terpenoids into isoprene units and their head to tail union is referred as Ingold special isoprene rule. And this rule is very suitable tool to limit the number of carbon skeleton of the structure of unknown terpenoids, because the arrangement is known. Okay. Finally, these compounds, how they are linked? Okay, this is head of one is linked to tail. Okay. Here also bicyclic compound, head to tail fashion. Now the last one is biological isoprene rule. Now plant synthesize variety of terpenoid, but free isoprene is never found in the plants. Instead of this, they contain high energy precursors of isoprenes called as isopentenyl 3 pyrophosphate, and so it is believed that in biological system the terpenes are synthesized from basic unit called isopentenyl 3 pyrophosphate. This is sometimes called as a biological isoprene rule. So, most of naturally occurring terpenes have carbon count in multiples of 5, 10, 15. That is, as isoprene units are built, the number increases. Students, with this, I conclude my lecture. Thank you.